Welcome to the Math 95 Unit 1 Homework Help video. So we're just going to go through some of these problems, do a quick review of the topics in them, and then kind of show you what's going on. And again, if you want the full lecture for any of these topics, you can find them in the video section of the 95 or 96 module. Again, there are a ton of in-depth topics in these modules. This is more of a review and just a quick little brush-up help. Let's start with the first question. We want to round 903 to the nearest 10. Okay, so 903 to the nearest 10. Well, that depends on where is the 10. Remember, this is the ones place. This is the tens place. And then you keep counting up from this. This is the 100. So to round to the nearest 10, we know it's going to look like this to start. Whoa, that's not true. So we know everything before the tens is not changing. Everything after the 10 becomes a 0. And then the 10 place is what actually changes. This is the part that actually gets rounded. So does this get rounded to a 0 or a 1? Well, this is closer to 0. Remember, if it's less than 5, it rounds to 0, or it rounds down. If it's 5 or more, then it rounds up. Because it is less than 5, we round to 900. You can type in our answer into My Open Math, check that we're right, and we're good to go. Let's look at another one of these. Rounding 11 to 18 to the nearest 100. So again, this is the ones place, the tens place, the hundreds place, thousands, and 10,000s. So the round to the nearest 100th, everything before it won't change. Everything after it is going to be zeros, because that's the whole point. We need to round to 100, so this have to be zeros after the hundreds place. Now the question is, do we round this down to a 2 or up to a 3? To do that, we look at the next piece. That's going to be rounding down. 11,200. Now if it were something like this, then we would round it to 11,300, because after the hundreds place is a 5, and 5s mean that we have to round up. Okay? But either way, here's 11,200, and that should be our answer. You can check it in here, and there we go. All right, next problem to review. Trying to find the list of ones I wanted to go over. Number 4. 3 over 40 plus 21 over 40. So for adding fractions, it's always important to first ask ourselves, do we have a common denominator? Are the denominators of these fractions the same? And if they are, we are happy. If they aren't, then it takes more work. So luckily here, the denominators are the same. To add the fractions, we just add the numerators together. Just like a half plus a half is now 2 halves, a whole. Well, we have 3 40ths, and we're adding 21 40ths. So now we have 3 and 21 40ths, just like so, which does simplify to 24 40ths. But this is not our final answer, because this is not fully simplified. This is not in lowest terms. They share common factors. For example, these are both even numbers. So we can divide the top and the bottom by 2. If we divide the top by 2, it's 12. Divide the bottom by 2, it's 20. And we can do it again. And in fact, Now, whether you want to reduce it all at once or reduce it in steps is up to you. We could divide everything by 2 again to get 6 over 10. We could divide everything by 2 again one more time and get 3 over 5. And that's going to be our final simplified answer. Now, you can also do this with a calculator. So we're going to be using GeoGebra. You can use Desmos. You can use a handheld calculator. There's a lot of ways that you can do it. But one of the ways is to just type it, 3, and then you can type the /, or if you want, there's probably a division sign here. There it is right there. 3 over 40, press the right arrow key, or you can click this button to get out of the denominator, and then plus 20, wait, what was it? 21 over 40. So you can either press the plus sign on your keyboard or click it down here. Plus 21 divided by 40. Make sure it looks right. Okay. And then press enter to have it update its answer. And it says it is 0.6. Now our answer was 3/5. 3 divided by 5 is 0.6. In GeoGebra, you can click this button to see your answer as a fraction. And you can see that it is indeed 3/5. We do this, it says reduce our answer in lowest terms. 3/5 is the correct answer. If we did 24 over 40, that would not be the correct answer. Okay, so make sure that you reduce and always read the instructions on these ones. Next up is what happens if you add with mixed numbers? 5 and 5/9 plus 3 and 8/9. Now the secret here is in how we say it. 5 and 5/9. 3 and 8/9. So this is really just 5 and 3 and 5/9 and 8/9. We can just add them separately. 5 and 3 is 8. And then again, we have a common denominator here, which is good. These have to match. And then 5 plus 8, all over 9. That'll be 8 and 13/9. But we're not going to write our answer like this. This is not a good mixed number because 13 over 9 is an improper fraction. We have to convert the improper fraction to a proper fraction before we can combine everything. So 13/9, we need to convert that to a proper fraction, or we can convert it to a mixed number. Well, 13 is more than 9, and specifically, if we look at this, right, 13, that's 9 over 9 and 4 over 9. We can go backwards. Just like what we did here, we can go backwards. Where did this 9 come from? Well, I want to know what it is as a mixed number. 9/9 is a whole. So this is 1 and 4/9. And now we have 8 plus 1 and 4/9. That's going to be 9 and 4/9 now total. All right, so a lot of concepts here. Remember, you can find the full explanation for these concepts in those full videos of Carly McAvoy. This should be our answer. 9 and 4/9. Oops. 9, 4/9. There we go. We got it. Okay. And there's a couple of ways of doing that. You could also convert everything to an improper fraction first. We could look at the same problem if we wanted. What if we converted it to an improper fraction at the start? Well, 5 and 5/9 that's equal to 45/9 plus 5/9. Where does that 45 come from? 45 is 9 times 5. So this 45/9 really is just 5. 45 divided by 9 is 5. If you have 45/9, you have 5 wholes of that thing. Okay. So again, there is a video on converting mixed numbers to improper fractions that you can check out if you'd like. And then we can do the same thing. Well, we have 3 wholes. How many ninths is that? 3 wholes, 3 whole things is 27/9. And now everything has the same denominator. We can add it all up and then simplify and put things as a mixed number that way. So you could keep on going this way as well. Just showing an alternative strategy to solving the same problem. Let's look at number 6. What if we have 7/9? Oh, no, not number 6. Number 7. 2/3 minus 3/7. Well, in this case, we don't have a common denominator. Okay, so we need to get one. We need to find the least common denominator, which is just the least common multiple of these denominators. In this case, the least common denominator is 21. They share no common factors, so that least common multiple is just what happens when you multiply them together. 7 times 3 is 21. So to get there, we have to multiply this guy by 7. But if we do it to the denominator, we have to also do it to the numerator. Because what you notice is that we're multiplying by 1. 7 divided by 7 is just 1. 7/7 is a whole thing. Multiplying something by 1 never changes it, right? 5 times 1 is just 5. 6 times 1 is just 6. So we can multiply this by 1 and not change anything. Here, we want a 21 in the denominator, so we multiply this by 3/3, which is still a whole thing. 3/3, one whole thing, so we're not changing this number either. But what happens now, if we chose these numbers, look at what happens. That's 14 divided by 21 minus, remember when you multiply fractions, you just multiply the numerators together and multiply the denominators together. Minus 9 over 21. Now we have a common denominator. Now we can actually combine these. So we had 14 21s, and we're losing 9 of those 21s. Well, now we're going to have 5 of those 21s remaining. We have to make sure we simplify. The only factor of 5 is 5 and 1. And 5 doesn't go into 21. So this is in lowest terms. This is fully simplified. 5 over 21 is our answer. There it is. You can also type this in on GeoGebra. So it is 2/3, 2/3, and you can either press the right arrow, and then minus 3 over 7. The answer is not 2/3, so make sure to hit enter again. Either press the enter key on your keyboard, or not that button, or maybe this key. There it is. So that's a big, long decimal, an irrational number. And as a fraction, it's 5 over 21. Great. Exactly like we wanted. All right, let's do a couple more. Do number 9. You have a piece of wood that is 13 over 16 meters long. All right, so a piece of wood, it's 13 over 16 meters long. So we could divide this into 16 pieces. Well, we could divide a meter stick into 16 pieces. And if we took the first 13, that would be this piece of wood. If you want to divide this wood into 3 equal pieces, what length would each piece be? So let's divide this into 3 equal pieces and figure out how big is each one of these red pieces. Well, we're dividing it into 3. That's the hint. So what we're going to do is then we are going to say, well, we have 13 over 16 meters, dividing it into 3. So we take that full length and we divide it by 3, and that's going to be the answer for our length. Remember, when you divide, you can write 3 as 3 divided by 1. 3 over 1 is the same thing as 3. You can check it on your calculator. To divide fractions, you keep the first fraction the same, you change division to multiplication, and you flip the last fraction. And now we're just multiplying fractions. We don't need a common denominator for multiplying. We just multiply across on the top and across on the bottom. 1 times 13 and 3 times 16 is 48. Again, you can set up multiplication like this to get that it is 48. And that is fully simplified because 13 is a prime number. That should be our answer. Almost. What am I missing? We need to know what the answer is in meters. Always remember the units of your problem. This is how many meters we had. We started off with 13/16 of a meter. We divided that into 3. Now each one is 13/48 of a meter. And we could find a decimal approximation as well. Let's make sure we read the problem and see what it wants us to do as our answer. Give your answer as a fraction, reduce to the lowest terms, and you need the units on your own paper, but you don't need the units from MyOpenMath. So you should have those units. You should be aware of the units, but always read the instructions to make sure that you're entering the answer in the way that it wants you to do. All right, let's do 2 more problems. No, actually, we covered that one already. Let's look at number 14. Order of operations. If we want to do a problem like number 14, 12 divided by 2 plus 7 minus 2 squared. You may have heard of the mnemonic PEMDAS, which stands for parentheses, exponentials, multiplication, division, addition, and subtraction. Now remember that the first 2 can be done in either order, parentheses and exponentials. Or sorry, hold on. Multiplication and division can be done at the same time. Addition and subtraction can be done at the same time. Okay, so we are going to start with parentheses, and then we'll do exponents, and then we can do either one of these, multiplication or division, and then either one of these, addition and subtraction. Those ones, the order doesn't matter. So we'll start with parentheses. So leave everything the same except what's in the parentheses. 7 minus 2. 7 minus 2 is 5. So we've done the p. Now we simplify the exponents. Leave everything else the same and deal with this exponent. 5 squared is 5 times 5. That's 25. Multiplication, there isn't any. Division, okay. Let's take out the division. Here I should show what we're doing in every step. 12 divided by 2 is 6. Leave everything else the same. Division's done. Addition, 6 plus 21. 6 plus 25. That's 31, and that's our final answer. There's no subtraction that we have to worry about. We get our final answer just of 31. We can type that in and see that we indeed got the correct answer. So that's a little brief review of these sort of topics. Let me know if you have any questions. And again, you can find the full topics in the 95 Unit 1 videos and notes. Fully explained, full notes, full videos, and you can just find the specific thing that you want to look for. Let me know if you have questions, and have a good one.